Hi, welcome to Arabella's Reading Corner. I'm Arabella, and today we will be reading Spidernaut Arabella, the Spider in Space. Weaving a web is hard work. I should know. I've had to do it on Earth and in space. I'm Arabella, the Spidernaut. Spiders in space may sound like science fiction, but my story is true. Back in 1972, a high school student named Judith Miles thought up an amazing experiment, and the astronauts at NASA thought it was pretty amazing too. Judith wanted to know if a spider could spin a web in space. Spinning a web is tricky. Common orb-weaving cross spiders like me make webs that look delicate but have to be strong enough for us to walk on without breaking. We decide how to spin our webs based on how much we weigh. But in space, we would weigh, you guessed it, nothing. That's because there is zero gravity in space, which is why astronauts look like they're floating. Can spiders weave web in space? Was such a great question that NASA decided to send my friend Anita and me into space. We wouldn't be the first insects or animals in space. There were fruit flies, mice, frogs, dogs, and monkeys before us. But none of those animals know how to spin webs, so our experiment was unique. We will travel up to Skylab 3, a space station launched into Earth's orbit by the United States in 1973, along with 3 astronauts, Owen Garrett, Alan Bean, and Jack Luzma. Web Diary, July 25th, 1973. Think of it, me, an arachnid, and a scientific name for spiders, just minding my own business one day, and then Spidernaut! I'm going to follow the footsteps of some of the great space animals before me, like Laka the dog and Ham the chimp. Maybe someday, people will remember my name too. The moment has arrived. On July 28th, we're given a huge dinner. Common spiders can live for 3 weeks without food, but this trip is going to last 56 days, so I hope they don't forget the snacks. Then we're put into vials that look like long tubes. There's only room in here for a watery sponge for me to drink from, an extra dead fly, just in case, and me. No room to spin webs in here. Think of these vials like our own private rocket ships for takeoff and landing. Strap in, Spidernauts. 3, 2, 1. We have liftoff. It was a bumpy ride aboard the Saturn 1B rocket that took us to Skylab, and the trip took more than 8 hours, but we made it. Web Diary, August 5th, 1973. I'm in space. I feel woozy. I can't tell whether I'm right side up or upside down. The astronaut who's taking care of me, Owen, tried to get me to leave my tube today, but I didn't want to. It looks scary out there, all dark and spacey. None of my 8 legs seem to be able to grab onto anything. I wonder whether Anita likes this feeling. This was not what I was expecting. Owen finally had to thump my tube to get me out. Oof! Look at me! I'm floating. Here I am in the cage. Home sweet home. The cage reminds me of a window frame. It's where I'll be swimming my web, spinning my web, if I can. Now here's the big question. How am I supposed to spin a web when there's nothing to attach it to? And why does it feel like none of my legs work? Owen called it moving erratically in a swimming motion. Have you ever seen a spider swimming? In space? More like flailing. I don't think it's possible to make a web here. Day 2. Still swimming. Actually, this isn't so bad. There's no up or down, but I'm starting to get the hang of this. This mesh screen on cage walls might be an okay place for a web. Maybe I'll give it a try. Web Diary, August 7th, 1973. Well, I did it, but it was terrible. My first web in space was a shaky, zigzaggy failure. I usually pride myself on making beautiful, neat circles, but not today. This wonky web has to go. It's just a mess of silk with more holes than strands. I guess I'll have to eat it and start again. Yes. Eat it. That's what spiders do. Web silk is made of protein, which I'll need for energy if I'm going to try again tomorrow. Day 3. My second web was much better. Web making is serious business. Spiders make a different kind of silk for each part of our webs. I start by making a bridge with really strong silk. It has to be strong because the whole web will hang from the bridge. Next, I make the outside frame using non-sticky silk because it needs to support me, not to help me catch a meal. Then I add the radicals, like the spokes on the bicycle wheel. When everything's perfect, I can switch to the sticky silk and start on my circles. Voila! It took me quite a few days, but I finally made a decent web. And I was the first spider ever to spin a web in zero gravity. That makes me a Guinness World Records Award winner. Spiders use webs for trapping and storing food. Up here, however, I will never catch a fly. Nobody told me there weren't insects flying around Skylab 3. Good thing the astronauts brought a container of dead ones. I think Owen has taken a liking to me, though, because instead of feeding me dead flies, he's requested a change to the experiment so he can give us bits of rare filet mignon. That's a fancy steak. Owen also took pictures and collected some of my webs to bring back to Earth for scientists to examine. Owen studied me for 3 weeks, and then on August 26th, it's Anita's turn. Like me, she doesn't want to leave the vial at first and even clings onto Owen's arm before being placed in the cage. But she adapts really well to being in space and can spin her web even quicker than I did. A whole day faster. Her reaction to being weightless is recorded on a camera and videotape. are some of the cool discoveries scientists find from our experiment? First, scientists wanted to study a spider's central nervous system, that's the network made up of the brain and nerve clusters, and in humans, the spinal cord, which controls body movements. Studying our movements and how our brains reacted to the lack of gravity helped researchers examine how different medicines and drugs might affect the human nervous system. Scientists found that spiders need to get used to near weightlessness before we can spin a good web. Even though we're born knowing how to spin webs, Anita and I had to get used to our surroundings before we could start. Our webs in space were about the same shapes on Earth, but the silk was finer, probably because the webs didn't need to support our weight. The silk in our Earth webs is the same thickness all around, but in space some parts are thinner, maybe because we start and stop spinning more often to figure out where to put the threads. On Earth, gravity and wind help us do that. Web Diary, August 26, 1973. I know my silk is tougher than steel, it's true, and much more stretchy and elastic, but who knew that I could change it based on gravity? I am so amazed and proud that I was selected for this adventure. And even if I never set 8 legs back down on land again, it has been an honor to have been part of this fact-finding mission. On September 25th, our mission ended. Astronaut Owen brought the samples of our amazing webs back to NASA after our nearly 2 months trip aboard Skylab 3. Judith, remember her, the student who brought up this experiment in the first place, was invited to the Marshall Space Flight Center in Huntsville, Alabama to examine the webs and photographs. Lucky girl. None of the astronauts knew what effect the experiment would have on us or our lifespans, which is usually about 1 year. Neither Anita or I survived long enough to be part of any further space explorations, but I'm super proud to have been one of the first Spidernauts in space. Since us, there have been many more. 2 orb-weaving spiders nicknamed Elmo and Spider-Man were launched aboard the Space Shuttle Endeavour on November 14, 2008 to visit the International Space Station. This project allowed students on Earth to compare the habits of the spiders in space to those kept in their classrooms. A few years later, from May 16th to July 21st, 2011, teachers and students on Earth watched video links following 2 golden orb spiders, Esmeralda and Gladys, as they adapted to life aboard the International Space Station. The videos even showed Esmeralda capturing a live fruit fly provided by the astronauts, adding a new twist to Spidernaut experiments. Another student project in 2012 sent Nefertiti, a Johnson jumping spider, to the International Space Station. Jumping spiders don't spin webs to catch prey, they leap. Nefertiti lived for 100 days in space and made it home again. Being a Spidernaut was a great experience, especially knowing that our experiments helped astronauts and the students back home who were cheering on us study and learn about spiders in space. That's one small step for man, but one giant leap for spiders. I hope you enjoyed this book.